Hi, Assalamualaikum. My name is Siti SYAIRAH binti Muhammad ARIFFIN. My matrix number is 144865. I'm from School of Mechanical Engineering Manufacturing from University of Science Malaysia, USM. For my subject EPP 212, Advanced Manufacturing Technology, my assignment 1 titles is Friction Stir Welding for Dissimilar Metals. So, for the introduction, friction stir welding is a solid-state joining method, which is the metal is not melted and used while the initial metal properties have to remain intact as far as possible. Heating caused by friction at the interface cause heating that heat needed to enter various specimens. Okay, friction stir welding is able to produce welds which have no defects, usually associated with processes of friction welding. So alloys like aluminium, copper, titanium, matte steel can be joined by friction stir welding. So this is a mechanism of work. Okay, so this one is a sufficient downward force to maintain registered contact. Okay, the pressurized layer is formed by direct interaction with the tool's shoulder and pin outside. Move to the trailing edge of the tool's hammer. Okay, so this is a schematic for friction stir welding. Okay, there are a few of friction stir welding process steps, which is started with a start spindle, followed by plunged into material, preheat, and traverse. Like the schematic before, a rotating cylindrical tool with a profile probe is fed into a boot joint between two clamp workpieces until the shoulder, which has a larger diameter than the pin, touches the surface of the workpieces. The probe is slightly shorter than the weld depth required, with the tool shoulder riding atop the work surface. Okay. After a short dwell time, the tool is moved forward along the joint line at the preset welding speed. Frictional heat is generated between the wear-resistant tool and the workpieces. This heat, along with that generated by the mechanical mixing process and the adiabatic heat within material, cause the stirred materials to soften without melting. As the tool is moved forward, a special profile on the probe forces precise material from the leading face to rear, where the height forces assist in a forge consolidation of the weld. So, this process of the tool traversing along the weld line is a precise tubular shaft of metal results in severe solid-state deformation, involving a dynamic recrystallization of the base materials. Okay, uh, this one is friction stir welding process parameters. Uh, the first one is tool rotation and traverse speeds. There are two tool speeds to be considered in friction stir welding, which is how fast the tool rotates and how quickly it traverses the interface. These two parameters have considerable importance and must be chosen with care to ensure the successful and efficient welding cycle. The second one is a tool type. Tilting the tool by 2 until 4 degrees such that the rear of the tool is lower than the front has been found to assist this forging process. It affects the bit characteristics and the appearance of the weld. For the third one is a downforce or plunge depth. The plunge depth is defined as the depth of the lowest point of the shoulder below the surface of the welded plate and has been found to be a critical parameter for ensuring weld quality. The plunge depth needs to be correctly set, to ensure the necessary downward pressure is achieved and to ensure that the tool fully penetrates the weld. The lastly is a tool design. The design of the tool is a critical factor as a good tool can improve both the quality of the weld and the maximum possible welding speed. It is desirable and that the tool material is sufficiently strong, tough, and hard wearing at the welding temperature. So the advantage for of friction stir welding. The first one is a good mechanical properties in as welded condition. The second one can be working in all positions, horizontally and vertically. The third one, automatic on simple milling machines, lower startup cost and less planning. Fourth, enhanced protection by lack of harmful gases or liquid contents better. Number five, a strong welding appearance and low thickness. Six, efficiency and cost benefits from fusion to friction transition. And lastly, no consumables. The disadvantage of friction stir welding is less effective than manual and arc methods. Okay, the second one is traverse rate is always slower than other forms of fusion welding, but can be offset if less welding passes are required. The third one is breakdown pressures needed for the heavy duty clamping. The last one in exit hold left when tool is withdrawn. So, the limitations of friction stir welding. Welding rates are slower than fusion welding processes, which is up to 750 millimeter per minute for welding devices with a 5 millimeter thick aluminum alloy series 6000. The second one is the workpiece should rigidly clamp. The third one is the keyhole at the end of each weld. So this is an example of parts manufactured by friction stir welding. Actually, application for FSW is wide in fabrication, uh, aerospace, automotive, and railway. So like this examples, friction stir process knife by Megaster, and this one is a log longitudinal and circumferential friction stir welds are used for the Falcon 9 rocket booster tank. This is for railway. The high strength low distortion body of Hitachi's a train British Rail class 395 is friction stir welds from longitudinal aluminum extrusions. And lastly is this one. The center tunnel of the Ford GT is made from two aluminum extrusions, friction stir welded to a bent aluminum sheets, and houses the fuel tank.